This is an easy way to remember end behavior for polynomials. The only thing you have to know basically to determine end behavior is your parent functions. If you know those, then the end behavior should be easier. So basically, the easy way to remember it is the quadrant. So if you have, we know in quadrant 1, my x is positive and my y is positive. In quadrant 2, my x is negative and my quadrant is, my y is positive. In quadrant 3, my x and y are both negative. In quadrant 4, my x is positive and my y is negative. And so this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So from there, all you have to know is where your parent function. So for example, if you have y equals x squared, you know what that looks like. So it's something like this. 2 goes to 4, 4, there we go. And when you're talking about end behavior, you're talking about if you're reading the graph from left to right, where are we starting? What quadrant are we starting in? And what quadrant are we ending in? So I'm starting in quadrant 2. I'm ending in quadrant 1. So basically all you're going to do is take this and say as x tends to infinity, then y, negative infinity, sorry, then y tends to infinity. So I'm just pulling up the negative here. Now it ends in quadrant 1, so these are both positive. So you just say as x approaches infinity, y approaches infinity, positive. Now if this was negative, let's do some more. Let's do y equals negative x squared. We know that's a reflection. So 2 goes to 4. So that reflects over. So when you discuss end behavior, you just look at that part and you say as x tends to negative infinity, and that means this way. We're also reading from left to right. Y tends also to what? To negative infinity. We're also ending in quadrant 4 here. So as x, and this is positive, so approaches large numbers or tends to very large numbers, then my y, and you can write your y as f of x, goes to negative infinity. So that's negative infinity. Now what happens is anytime you have negative, anything with square, say I'm just making something up here, it has the same end behavior because all you're doing is looking at your lead here. And this resembles y equals negative x squared. The same thing happens with y equals x to the 4th because it's even. So, or negative x to the 4th. And for this one, you could say the same thing happens for y equals x to the 4th. It would have the same end behavior because my degrees are even. So if I had something like y equals 3x to the 4th minus 2x cubed plus x squared minus 1, then all you're going to look at is your degree, and we know it's even, so that means we're starting in quadrant 2, ending in quadrant 1, so this is your end behavior here. And you're just pulling up the positive and negatives parts. All right, let's do the odd ones. So if you have y equals x cubed, we know that it looks like this. You have to know your, I'm not graphing this very well, but it goes something like this. Let's go up a little more like that. All right, it looks something like that. So reading the graph left to right, we're starting in quadrant 3 and we're ending in quadrant 1. So that means you're going to write your end behavior as this. These are both negative, so you write as x gets smaller and smaller, tends to small, so does your y. And then for this piece here, as x, because this is positive, so as x tends to larger and larger numbers, so does your y, because that's positive. All right, and let's do the negative. So if you do y equals negative x cubed, so let me graph this one better. That's just a reflection over the x and the y. It's an odd function. All right, so there it is. So where are we starting when we read left to right? We're starting in quadrant 2, and we're ending in quadrant 4. So this is where we start, and this is where we end. So as x tends to negative infinity, our y tends to positive infinity. In this one, we're in quadrant 4, so you write this part. As x gets larger and larger, goes to infinity here, our f of x gets smaller and smaller. The numbers get smaller. Now this would apply for all numbers, so if you had something like y equals negative 3x cubed plus 2x plus 1, say, then all again you're looking at is this cube, and in this case it's negative, so you would use the same end behavior that we have here. And these are called the power functions. And the same thing would be for if we had y equals x to the 5th. Anything odd, that one's just going to be even narrower. So it's going to be narrower in here. Has the same shape. Therefore, we're reading our graph from left to right. So as x gets smaller and smaller, and that's, whoops, it's negative. See the negative? You see the negative here. So negative infinity, our y, or f of x, is also smaller and smaller. So as we go this way, we're going down negative infinity to negative infinity. And then, so that's quadrant 3, and we're ending in quadrant 1. As x tends to infinity, y also tends to infinity, or you could just use that. As x gets larger and larger, y also gets larger and larger. Okay? And anything with the odd power is going to be quadrant 3 and quadrant 1. Let's just write that. So anything with the even power where n is even, you're starting in quadrant 3 and you're ending in quadrant 1. And anything with the odd power where m is odd, I'll just write this as m is odd, then you're starting in, actually on the even you start in quadrant 2, sorry about that, and ending in quadrant 1. Anything with the odd power, you're starting in quadrant 3, ending in quadrant 1. Quadrant 2 is negative positive, quadrant 1 is positive positive. Quadrant 3 is negative negative, quadrant 1 is positive positive. And it just makes it easier if you know it that way. Thank you and have a nice day. Bye-bye.
Class, Miss Shaw's class. Boy, I love math. Miss Shaw's class, Miss Shaw's class.
Don't fail! Watch Miss Shaw's videos for free.